this year's session of distinguished lectures in mathematical physics in memory of Matera and Prime Internet. So this year's speaker is Boris Feigin from Jerusalem Institute, teacher and good friend. Previously working for many years in Moscow High School of Economics, being the head of laboratory of representation theory. Okay, so
thank you for invitation and learning actually with friend that we work together also and some sense continue. Anyway, what I want to talk about and the subject is yes, and the latest story, the corresponding Vertex, so on. And let me maybe start. Today, the two lectures. Today, I maybe explain some main ideas. Tomorrow, if it will be possible, some detail. But let me start with some kind of motivation. And maybe after I will say more precisely about what will be afterward, but maybe motivation is rather broad, and it is from different elements of our story. One from representation theory, other, maybe others from geometry. Yes, and this second story I want to start with, and this motivation is following. We know from many points of view that all like algebras are acting in some geometric object of different kind. And for example, which I mainly want to discuss is following. Both very open stuff. So suppose Hn is given of points on a simple case. If you see two later, it will be more complicated case. N is how many? Or more precisely, the element of this manifold is what is polynomial trained into variables, this set of ideals of convention N. Surely it has many ways to think about this manifold with this keyword language and so on. But anyway, this is important story. And important manifold. And to follow different people, Kajima, example, and so on, what we are, and they are some version of instant on manifolds, which maybe not surely the easiest case, but easy enough to study. Yes, anyway, on this manifold, we have action of this part then yes, and they are acting on by natural way, by their analysis. Yes, therefore, surely they are acting. Yes, and after that, the topological object, which is here, is we consider case theory, equivalent case theory with respect to this, on this H. We sum up this by n, and yes, and whole algebra because they appear here because of many reasons. Yeah, actually, we can think about it as a space of representation of something. And this is the natural object where whole algebra is acting. And it is acting by correspondences. And maybe it is not reasonable to explain now details, but the question is that some algebra is acting on this space. Yes, and this algebra is a sort of full algebra, and I explain in a moment what is it. But the name of this algebra is J1 down here, or sometimes it is called the algebra. It has other many names, but what is this? So let me say first, if we are talking about algebra which is acting here, because it is equivalent cosmology, this is something over the base of equivalent cosmology of a point. So therefore we have C star times C star, and actually this thing is a sheaf over this. And if we are talking with what is acting, we can simply take a point here, which is Q1. This is standard notation, and we can say that the case theory of this HN, I mean direct sum by n, the something dependent in Q1 and Q2, and again, simplest way to think about it that we have algebra which depends on Q1 and Q2, which is a. So we expect to have some parameters. And that description of the algebra, which I'm talking about. So the simplest possible way to say what is this, and also explain why it's calling J1 double relative, that is also very old and standard is. So let us start with the algebra X. X inverse. Just this as a commutative algebra, this is function constant star times star. Yes, and this is closed. Therefore, such algebra as commutative algebra function on the totals. Yes. First of all, we have for this algebra deformation. Deformation, if it gives us something which is called non-commutative torus, it just which we have relation like this. Yes, it was written like simplest possible quantization of this commutative algebra, and this is functional non-commutative. So then next step is following. Because this is associative algebra, we can consider this as B with the operation standard operation minus. Yes, and what we let us develop this algebra by A, and is depending in parameter Q. Yes, and first of all, this algebra after deformation has natural representation in space C, maybe X inverse. No, some confusion, but still like the operator EX acting here by product by X inverse should reversing and operator D acting by Q. In that, so we can think about this algebra when it is acting here as the algebra of difference operator. And so by the way, this algebra it can be understood as some analog of J infinity. No, because it is acting in this space, that this is infinite dimensional space, and we have infinite matrices which are acting.
What is shift in here?
Sorry.
What's the shift?
Shift by
The
Q.
Act?
Shift by Q.
Okay.
X goes to Q. Yes. And so that we just and so well, and after this, essentially algebra A can be quantized in the following sense. So if we have the algebra and if this Lie algebra has a structure by algebra, so it means that suppose we have any Lie algebra. No, maybe let me say, and suppose it has two things. One thing is invariant quadratic form, like killing form, but we need invariant non-degenerate possible form here. And second, if A has the composition A plus A minus, this is the composition as a sum of two vector subspaces. Each subspace is the algebra, subalgebra, this and this. And we suppose, so this is the subalgebra, this is the subalgebra. And we suppose that A plus and A minus are isotropy. So this is usually the initial data for quantum group business. If we have Lie algebra with such structure, we can take universal model of A and for main people, we can make up deformation something. Yes, and in this case, it is such kind of structure. First of all, on this algebra, it is trace analog method, which is maybe not real trace, but this is trace sent from to 0 first, and This is very simple in this case because element of this is the summation xij xij and it's ended to a0. It is a coefficient in front of 1. Yes, and it has all properties. And if we trace it, we can hook up their analytic given form x, y is array. And this is almost no, the generate the kernel is 1, but it is not very important for us for that. And about such decomposition, it is possible to say by the following way. So let me draw dots. It is letters, and they are labeled the bases here. For example, this dot is for 1, and squared, and inverse, minus 2, here x, inverse, and so on. Anyway, it's clear what does it mean. Xi, j is now. So if we want really have such decomposition, it is better to consider something like SLN. So kernel of trace. So it means that you have this. After that, one algebra A plus is this, and a minus is this. So we have a plus, and we have a minus. Yes, and so if we have this in principle, maybe for infinite dimensional algebra it is not theory, but for finite dimensional we have theory. Of cardinality is important, maybe other people also. But if we have this, we have more or less canonical context. In infinite dimensional case, no such theorem, but it is different. Okay? And we can make up quantization. So after that, we get something like quantum input, or which is so how to develop it. Maybe it is one, but it depends in two parameters. One, we have q, which q1. It is the q here. And second, this t. Let me denote it by q2. And by the way, it is good to have a second q, say that q1, q2, q3, flat. Because of some reason it is natural. Anyway, such kind of things appear. This is parameter for difference operator. This is quantum parameter, and this is some efficient story. Yes, and people discover also many years ago that such things algebra is symmetric with respect to Q1, Q2, Q3. This is an important point, but let me skip the details. This is how much. And why I introduce it? Because if we return to geometry, then this equivalent is here of Hn by n. These are measures representation of this algebra J1. Now, yes, from this point, this is some version of Nakajima business who what he did, he considering space of representation. Here, for example, and after that, what algebra is acting here. And this is some special example of his story. Then maybe let me mention only that this algebra is acting in some related geometric object. For example, we can take same HN, and after that consider what is calling usually not Hilbert scheme, but Giesecke. Now, Giesecke scheme, it is some kind of story again, probably better to skip, but usual Hilbert schemes is related with the group G1 in some special sense. And Giesecke related to Gn. And in principle, Giesecke can be constructed by any group, but for this business, we restrict ourselves to Gn. And I want, so this is manifold of some special sheets also on steel C2 and degree n and with some conditions they form algebraic parity and algebraic manifold. We can ask the same question. Algebra which is acting here, and in fact, given this replace which we can suggest that the algebra which is acting is the same. This algebra is good for such things, and many people there's some collection of very interesting, natural, and beautiful algebra, and the question of physical geometric construction of representation to find how, no, it is topological way or other coherent chips way, and doesn't matter, but it is natural question to find out some algebraic manifolds that we can see if asked the example of representation of this algebra. So we are talking about this. So let me now say a little bit more about this story. That you have this algebra J1 double F, depending with U1 and two, and such kind of algebra has so-called conformal of vertex operator algebra limit. It means that we can send Q1, Q2, Q3, Q1. Yes, and each UI is U times the difference of I, and such epsilon I goes to 0. It is a limit, all of them go to 1. And such algebra has a rather interesting limit. And no, interesting and non-trivial. I cannot, maybe I can say something next lecture on the end of today, but this algebra has a precise description in terms of generators and relations. We can make up such limit in terms of generator and relation, but the important and non-evident story that in a limit we can find some vertex operator algebra. And if vertex operator algebra, then we expect some distance related to vertex separator algebra, for example, can follow field theory and things like that, and some not only that, and some kind of physics behind of it. So in some sense, all for code, we have some modular space which are shifts on the Hilbert scheme. We can move to algebra, which is affecting there in our case. And still this moment, it is just algebraic geometry, nothing more than that. But after that, we can expect, because of many reasons, really see. It is not only that, but some kind of vertex separator algebra is here. This is, yes, and
sorry, could you clarify that? The formula there, you want QI to equal Q to the power QI?
no, it means how to make up this thing. But then, this I just take some Q and suppose QI go to Q times EI. After that, this EI will proceed. So some process of going to zero depends on you choose one, two, and three. Actually, some of them equal zero, but you choose it and then go. Yes.
So we keep the ratio, right?
Yes. It's result depends on the ratio from one or two. Yes. So. No, I return to discussion of this story, but no, about this modular space business and so on. There are many examples of this story, but not so many where you really can calculate something. Yes, and because I want to talk about such kind of shift with algebra, let me first formulate my program, which is here if we just want to make one small step from Hilbert's rod. So the generic story, which is so if X is some algebraic manifold, then we can consider Hilbert's scheme of this manifold by a similar way. And if we have the action of some group, which is the simplified the situation, we can take this sum of n, and we can ask what is acting here. So it is very natural question from physics which makes us so. First of all, if the dimension of x is bigger than 2, then the question is very natural. We want to know what it is, but we are all people who have not enough tools. It is possible to formulate many conjectures, but not a real story. Some results, but very few. If x is 2, situation is much better. Yes, it can be C2 or more complicated. K3 surface, for example. But even for K3, it is not so easy to study. Some other things also. So let me consider from this point of view, again, next make a small step and the simplest example. The simplest example is 4. Let us take a line. Yes, and let us take line bundle O n. and it gives me the space of this bundle because I want to take this as x. It has that projection 1 and fibers are just lines. Yes, and it is it's non-compact manifold, but C2 also not. And it can be called a simple example of linear surface because it's constructed from any lines. Anyway, it is some manifold international, and we have the action of the star times the star here, and so we have something like Q1 and Q2 plus Q1 and Q2. I'll say later, but once you start acting here, because on the CP1, I'm surely acting some star is 2 fixed points. This one 0 and 2. And other C star acting along the fibers. Yes, and it will have delimitation in different direction. So we have such kind of force, which is acting from this manifold. And in simplest example, we can take no, it is X, so we can take this, and then we can look to what is acting. Also, good examples, and the simplest and most studied question is following that we can take C2, we can make the equations 2 over C2, which send V1 2 minus V1 minus Z2. It is singular manifold with quadratic singularity. We can consider the realization of this singularity, and the result gives me the manifold of such kind. So it is C1 here, and N is minus 2. So it is some manifold with CP1 such that certain perception number is equal minus 2. Yes, and so this is resolution of singularity, and this line is reached. Yes, and so after that we can ask the case theory and ask what the algebra is acting here, and the answer is 4. That no, it is also an algebra similar to J1 double head, but in reality it is like that. So what is this? We can repeat the same construction, but we can modify it a little. We can take C X inverse, inverse times the algebra of 2 by 2 matrices. So what is it? It is algebra of difference operator, and the coefficients are 2 by 2 matrix. What we can do? We can take the algebra from that, then find out the same structure, and trace, and decompose as a plus and a minus. It's again details are skipped, but after that we can make up also algebra and the algebra, and one day that this is the algebra still depends on Q, which is Q. And also some kind of T which is quantum deformation, still two parameters, and so again, it is not so easy to expect it, but in fact, such algebra acting on such kind of is yes, but yes, a question which where all people who are doing this business asking as a first or second question about storage. Suppose M is not -2, but some n. So what is happening in this case? Yes, and what kind of algebra? And no, well, because we have a construction through correspondences, it means that in principle we have this algebra. But we do not know much till now about properties of this algebra. And really, this algebra has no name, it is substance, just some algebra. So it is good to study. And, no, this question, let me explain. This is the question. This parameter n is, and what geometry thing asked about this algebra? So we what is going on? So the story can formulate by default. Well, we have my x is like that. C star times C star of x here, and there are two fixed points. Listen. Yes, and we are talking about correspondences which are active. And surely some correspondences changing shift in this point. These are correspondences which have support in one fixed point. And again, it can be defined precisely, but it is more or less clear. Second type of correspondence, concentrated this point. And but a situation around this point we will just see. And around this point, this is opposite. Yes, and because these 2 points are separated, there are some distance in that, then in the algebra we expect to have one integral and second integral. So again, there's our correspondences which are changing shift 1 point reading on point. Yes, and they are also some correspondences which changing shift on CP1. And so the algebra which we expect to have algebra, it contains one coefficient J1, second coefficient J1, and the whole algebra, no, because these points are far, that corresponding to J1 double coming. So you can say this algebra we have to therefore, algebra is now only expected, but it will be in reality, is extension of product of one product of R by extent by subs. Yes, and so if I'm talking about extensions, that for example, it means that no, because the algebra J2 double hat appear in this business, then J2 double hat is an extension of such kind of problem. But this the algebra, they know, maybe it will be clear in my second lecture that it gives us some descriptions of J2, but in some sense not that. Okay, and why for J2 double hat it is natural to expect this a little bit non-precise argument for this algebra here as the formation of this new algebra. So what is this? This new algebra is it has four matrix elements here, 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 and we have two algebras here, just J1 double hat, but before the formation, the algebra. And it extended by this and this. So this argument shows that something like that has to exist, but no, it is good here, but as precise statement is not correct. Anyway, it is something. And so
it is the X here where A equals anything.
what
The ln is any integer now of the good.
now this if we are talking about J2, it means that n equal minus. But in general, we have a family of algebras A defined in N and J1 times J1 is here. Yes, so this is the structure what I'm talking about. Next, what I want to say is this one, that so if I will have time, I return to geometry today again, but forget about this for a moment and let us go to some algebraic construction, which is important for me. This algebraic construction is it can be called by affine define pattern B. Yes, and it is strange that it is related to the geometry, but it is this. And by algebraic construction or algebraic defined change in business, I mean the following. If we remember about Euro defined change, then what is defined change, they are studied equations. So you have algebra JN, you have subalgebra JN minus 1, you have representation V. No, you can use it also that not necessarily finite dimensional, but suppose finite dimensional for a moment. Then I restrict So it is JLM representation and restrict JLM minus 1 and write down the right sum of the alpha and main result or starting say starting point. Differentiation is that they're saying that here multiplicity of representation which appear in the sum is just one. Yes, so if you have some highest weight here, you can determine highest weights which appear here, and it is some kind of direct sum. And if you continue procedure from J1 to J1 minus 2, then as a result, at the end of this story, you get a weight. And multiplicity is 1. This is because if we have J1 and J1, we can say what is usually called the cassette algebra or something like that. I do not want to define precisely what is this, but if you have algebra and subalgebra, yes, and if you do the same business, that V is representation of this, we write down this sum alpha, maybe with multiplicities and times the sum multiplicities, please. Cassette is algebra, subalgebra here in universal group, if it is the algebra, but it can be defined in much bigger generality. This is some algebra which is based in here, on space of multiplicities. So space of multiplicities are representation of some algebra which is sometimes defined by this. And in many cases, they can be described precisely, and it is interesting analysis. This is one of the important possible two inputs. So later, I chance ask the question. But suppose we have the same story. But we take JN plus JB and subalgebra JN minus K, where K is some number, not necessarily 1. We can ask the same question. I can take restrict increase. We have space of multiplicities. And we can ask what algebra is in K. But if K is 1, multiplicities of our dimensions, it is related with the fact that for K for 1, corresponding cassette algebra is correct. But if N K is bigger, then multiplicity is something. And it is not finite dimensional, but they are not one, they're finite dimensional. And I chancely found that the algebra which is acting here, this is a quotient of Langlands. So this, so all this was done, I think, 30 years ago, a little bit more than that. And Yang was discovered some time before that. But in that time it was new things, but anyway, he found that this algebra by some strange way appeared here. Yes, so if you are talking about Yang algebra, yes, and Yang is something like the priest had some kind of quantum version.
What role does N play?
And play the following. that we have some algebra that is called Langlands. This is a math this. But this algebra is much bigger. And this, in fact, this is embedded some function by idea of depending on n. Yes, and if n is big, going to infinity, it will be a sort of embedding, but for finite n, this is function by some idea. So in this case, n is but so if we are talking about generalizations, these for affine algebra, this means the following. Yes, it means the following. We replace algebra JLN with JLN. Yes, and no, in for affine algebra, we have representations here that condition representation with highest weights. No, they're infinite dimensional and depending on some additional parameter, which is central charge, some element in affine algebra. But question is the same. So we have some representation, which is a representation of J1 and head. We restrict the JL and times 1 head. So R with the sum of R alpha, and also their multiplication spaces, they are not 1, even with this minus 1 here. And we are also asking what is acting here, what algebra is acting here. And yes, and this question has a very interesting answer. Now, first of all, let me make jump a little bit. But I mean that the algebra J1 double head appear in this distance. It appears in this distance by the following way. So first of all, if you want to have this toroidal J1 here, better to consider not usual JLM, but affine quant. JLM head for usual, this also has meaning, but let me use it like this. And the statement is the following, that it is a man from the algebra J1 alpha to UQ of JLM such that the image commute with JL with UQ JL time this is no, I claim but such kind. So it looks like in some sense the trivialization of Aishansky, even in this case. But you can ask me where we can find parameters. So one parameter is here. But for universal development of the JLM head, it is some parameters which is maybe Q times K, which is left. K is left. So these things, because of that, can be understood as the algebra depending on two parameters. One Q, second is K. And because of that, this algebra, which pretends to be commutative of this, also depends on parameters. And actually, it is not precisely, but it is close to parameters to one, which this algebra it depends. And
what happens in the Alshansky construction if you use quantum group? Like not
no, it is direct the generalization of Alshansky to quantum group, and affine algebra go to Yangian go to affine algebra. Yes. So all this logic is okay. Only the question is why such kind of things happen. But so a little bit more is performed that if we change one here by some other number, so no, again about this. This is a story about this toroidal algebra and so on. But if all Q goes to 1 and algebra become Vertex toroidal algebra, then some interesting and nice things are happening. Maybe I mentioned about this later. But now I want to say the following. We have UQ. We have UQ. Here. And following Alshansky, we can ask what, well, what is happening here? No, well, again, naive and it is correct if I raise this. As I'm saying that usually Alshansky generalization, and here James he had universal enveloping is embedding here and can use it with this. Yes. And if we put hat everywhere, that hat appear here also. And no, it has expectation, but the result is that we this. So we have UQ of J and P, which we embed to J. And if commute is UQ of J and M minus P. And yes, and so this is such kind of story. Now, why I'm talking about this and what is a relationship with John? Really?
So guys, if say one of the levels of either side of either GLN or GLN minus 1 is critical, is there like something interesting happening?
Yes. Okay. No, it's critical. Well, very remarkable things like that. But as usual, the critical level in some sense simpler and in some sense more complex. It depends on what you ask. But for safety, here I suppose there will be generic, but actually it is not. But anyway, what is the relation with German? Let us look at special key. We can have Q J N and we have embedding here JN minus 1 here. And we have embedding here of JN minus 2. Yes. And because of this, and if you with me that first of all we have JL2 down here, which is going here. No, which is going here. But can you see this? And we have J1 here, which is going here, which can include this. And we have second total on J1, which is going here, can look, and it is no, because I did not explain right precise formulas, but you can believe me, and it is natural that because of this, we can say that no, if we erase all in between, what's that? Okay. Do we have?
One of the 10 top.
Yes, yes. It's fine.
Yeah.
Maybe this case. So in this case, we have universal model control in one we have, and because of this story, we have J1 times J1, each embedded system. So me is as here. No, universal and everywhere. So from this, we can again make natural conjecture that this algebra is the extension of such part. So it looks like completely different way to make such extension. And no, because here J2 double headed here, it means that my parameter n, which was in this geometric side, is minus 2. Yes, so so this very special, so how to say, this very special surface, linear one, where this CP1 and this line 1 local minus 2 is here, in some sense, by some strange way, it is hidden in this defined safety construction. This is very also interesting and nice stuff. Yes, and I want to say that so at least part of my talk based on non-old field paper with Nietzsche, Glimmer, and Jenny Moody. And we tried, no, because it is for other end with a big question what it is. So it is just try to take some n and try using some reasons, try to construct this explicit. So it is some algebra which contains to this J1 double head or Octobre sometimes it is called. First of all, it is not great case in point to find what parameters of these two. I did not explain how parameters Q of this algebra and this algebra are located. But from geometry we know because it is some torus act. And one Q something happening around one point, second happening at other point. Because of that, we know it. And it is interesting that this differentiation story gives us precisely the same relations of parameters. Just yes. So what we try to do, and it was not easy, to take some n and take this product and write down additional generators and try to find out the relations. We do not succeed fully, but it is very interesting story in a way. And tomorrow I will try to explain something about it.
So that's the question.
So this parameter n on the geometry side had nothing to do with the n parameter in the algebraic side. There was an n here of the GLN, and there was an n in the geometry side, but they're not related.
No, no. Just the same name.
and you said the same extension by this product of 2 GL1 has.
Yes.
And what's the other, like, what's the quotient?
Motion over.
I mean, the inclusion of this, what's the, you have a short exact sequence, what's on the right? The short exact.
No, but it is not more than that, it is less than. So for example, if you take usual Jn plus m, you want to say that this is extension. So you have Jn, here you have Jn. But if you go to the sum to the whole algebra, you have to add here one representation of the product, and here another representation of the product. After that, write a relation. This special case, this commutative, but they rated this something. So if you want what actually is going on, so in this case, we have one J1 double head here, second J1 double head here, but here and here are some representation. Yes, and after that, we need to say how they talking to each other, to themselves, what it is. From geometry point of view, it means that it is if you want, we have to one which is here, but this and this related with some correspondences, which are changing shift along this line. Yes, but no, it is like that. The situation is not so simple, it's not so. But philosophically, clear.
Are these representations no? Like are these part modules or at least J1 have that?
No, in what case? So if you consider Gilbert scheme, it is a sport representation. If you consider a resolution plane singularity, it is also sport representation. If you are talking in general case, you can call it folk representation if you like. But the question is folk representation of what?
Yes. And in this at the beginning of your talk, to introduce this algorithm, the J1 act with the parameters.
Yes.
You had this algebraic side at first with the HN of C. Okay. And so you have this algebras depending on the x, x-1, d-1. Is it clear where this, like, there's this SL2Z symmetry on this J1 at which is related to this thing called Mickey's isomorphism, I think. Can we see it in this perspective?
Not easy, relatively easy. I want to say that if you are thinking about the new algebra,
Yes.
the mirrors that on the algebra, the SL2Z takes is rather natural because basis is just two-dimensional letters and the SL2Z is written.
Okay.
No, the fact that we can make it after quantization, no, they are some generic arguments that it is true, but it cannot be easy. So that,
Okay.
but it is possible to check relative the same.
So instead, easier to switch from the geometric side, from this algebra.
Yes, it is.
Yeah, one section. So it looks like there are several possible ways to split this version of geo infinity into parts.
Yes.
But how much this changed? So we should be splitting line differently. So what actually changed?
No, I can say that first of all, that how to say it's very, very, and first of all, how usually we expect if we have the algebra and if we make a splitting plus and the minus, that you can deform it if the algebra is common multiplication. If we change splitting to different algebra, this is still the same story appear, but the multiplications can be conjugated or not. Finite dimensional case, which usually yes. Infinite dimensional case, sometimes yes, sometimes no. Yes, and no, this story is very, very much related to what multiplication we use. In geometry, like one vertex operate an algebra is like the art. Yes. And from this point of view, they're really different. SL2C is active, but it more or less means that we are dealing some, no, in this case, not, but in more complicated cases, we deal with different representations. But anyway, SL2C is a key point here on many open equations.
Does this like n other than any meaning from geometric side? I understand that you send it to infinity, but are there any traces of this n in geometry?
No, in geometry is not so easy to see the role of n because what is going on? You can take that JM head over JM minus one head. You can develop over this with one double head, but it depends on. So as I said, actually, because this algebra is bigger, therefore fixed affine n, actually this is an embedding of some ideal depending with n. And as I said, in finite dimensional case, algebra, which was young, does not depend in n, but the ideal. In toroidal case, in this case, this algebra depends. Yes, and this n actually one of parameters. Yes. Now algebra depends actually in three parameters. One is to three, and is one and left. You want to do parameters. What I said is u here. Yes. Second parameter is level. The third parameter is this n. So in some sense, it exists. But to see, you know, if you think that geometry is the first principle from where I was going, this I can. But it is there.
I mean, potentially you can take some element of this ideal by which you quotient, and you can ask like what correspondence this acts by this element of the ideal. And yeah.
No, I can't. No, question is national, but no matter.
No, bread construction is it possible to make n parameter,
Yes.
like complex parameter.
Complex parameter. This is in the construction n is integer, but if you look carefully, n is complex number. So it means that it is usual story which we all like. JLN exists for integer n. JLN minus k exists on also for integer n and k. But quotient cassette k surely have but n good methods. It can be complex now.
So it is like the algebra contomorphisms of some function, and you can generalize it. The case, the multiple cases.
Yes, we can say in 5 pieces.